Hi everybody, this is Mrs. Snook with section 8.2, Arithmetic Sequences and Partial Sums. So in this lesson, we are going to focus specifically on what's called arithmetic sequences. And we are going to recognize and write the nth term of arithmetic sequences. We can also find the partial sum, and we're going to use these arithmetic sequences to model and solve a real-life problem. So first up, let's talk about what an arithmetic sequence is. And what that means is there is a common difference between every single term in the sequence. So our first one, we have a sequence whose nth term is 4n plus 3. That common difference is 4. So if I was to write terms for that sequence, and I would start with n equals 1, what I would write is 4 times 1 is 4 plus 3, so I get 7. Go on to n equals 2. 4 times 2, 8, plus 3 is 11. Now I'm going to do n equals 3. 4 times 3 is 12, plus 3 is 15. And let's get another one. Let's do n equals 4. 4 times 4 is 16, plus 3 is 19. And this sequence would continue. So check this out. We have 7, 11, 15, 19. There's our common difference of 3. I also want to point out to you that it would be a linear sequence. If you were to graph these points using n as your x and then these as y's, you would get a line. And remember, with lines, your equation is y equals mx plus b. Well, guess what? Here's m and here's b. So that common difference, that is your slope. And then this plus 3 on the end, that's like your y-intercept. Take a look at the next one. We have the slope whose nth term is 7 minus 5n. And because the common difference is negative 5, you have an arithmetic sequence, which we can also model with y equals mx plus b. So if you were to plug in some numbers, and we always start our plug-in with n equals 1, start there. Then what you get is 7 minus 5 times 1 is 2. And then plug in 2, 7 minus 10 is negative 3. And you could just keep going by plugging in n's, or you could remember your common difference is negative 5. So I just take negative 3, I add a negative 5 to that, I get negative 8. If I add another negative 5, I get negative 13. And it's actually easier to figure out your terms if you start using common difference. All right, so now what we're going to do is we're going to find a formula for the nth term of the arithmetic sequence whose common difference is 3 and the first term is 2. And so I'm just going to use, like we've been using, I'm going to say y equals mx plus b. Common difference, that's going to be our slope. So I have 3x. My first term is b plus 2. That's how we would do it if this was a linear function. But we're in sequences, so I'm going to change letters to use sequence notation. So change letters. For sequence notation. So if I change my letters, instead of y equals mx plus b, I'm going to say a sub n equals 3n plus 2. So change the y to a sub n, change the x to n, and then you have your equation. A sub n equals 3n plus 2. Or take your common difference, multiply it by n, and then add 2. All right, so now we're going to write the terms of an arithmetic sequence. I'm given that the fourth term, so fourth term is 20, and the 13th term is 65. And we're going to write the first several terms of the sequence. Well, to do that, I need to have the formula. And arithmetic sequences, remember, they work just like linear functions. So I'm going to use our tools for linear functions to write an equation. So I know that fourth term is 20, and the 13th term is 65. So I've got 2 points. Slope is going to be y2 minus y1, or 65 minus 20, over x2 minus x1, 13 over 4. So I get 45 over 9. That reduces to 5. That's my common difference. Okay, the next thing I'm going to do is figure out the equation of the line using the slope. And what we can do is we say y equals mx plus b. I have an m, I have a 5 that I can plug in. I'm going to use one of my points. I'm just grabbing that one because it's first. I'm going to put the 20 in for y and the 4 in for x. So 20 equals 5 times 4 plus b. So that means that in this expression, I only have one variable, so I can solve for b. 20 equals 20 plus b. Subtract 20 from both sides. b is going to equal 0. So that's my first term. It's not letting me write. So I have what I need to write my expression in my sequence form. A sub n is going to be 5n plus 0, or just a sub n equals 5n. Now it's asked us to write several of the terms for the sequence. So let's just go ahead and write some. So I'm going to always start with n equals 1. So here are the terms. 5, 10, 15, 20, 25, 30, and we could just keep going on. Notice our common difference is 5 between each term. All right, so that's method 1 for doing sequences using linear. Second method is a formula. We have a formula that works for every linear sequence as long as you are given the first term and the common difference. And that formula is this: a sub n equals a sub 1, that's the first term, plus n minus 1 times d. A sub 1 is first term, and d equals common difference. And it's going to be the number of terms. So it says here, find the 9th term of the arithmetic sequence whose first 2 terms are 2 and 9. So I'm looking for the 9th term. That tells me that n is going to equal 9. And my first 2 terms are 2 and 9. That tells me a sub 1 equals 2. A sub 2 equals 9. Now to get the common difference, since it's going to be the same, all I have to do is subtract 9 minus 2. So my common difference, or d, is going to be a sub 2 minus a sub 1 equals 9 minus 2. That equals 7. Now I have everything I need using the formula to write my expression. A sub n equals a sub 1 plus n minus 1 times d. Just plug in what you know. So a sub n is going to be 2 plus 9 minus 1 times 7. And in this case, we're looking for the 9th term, so I'm just going to put a 9 in there. So a sub 9 is going to be 2 plus 8 times 7, and you get 58. All right, the next thing we're going to do is we're going to find the sum of a finite arithmetic sequence. So finite means it ends. It doesn't go on forever. So we're going to find this sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Option 1 is to get your calculator and add all of them up. And that's fine if the sequence is small enough. Like you could add up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. We have 10 terms in here. And you could simply get your calculator and just add all of those together. And as I was saying a moment ago, if the number of terms is small enough, there's no problem doing that. However, what if we get a huge number of terms? It does get to the point where it's very tedious, it's very daunting, and trying to add up all of those terms by hand is very annoying. So lucky for us, we have a formula that helps us with that as well. And that formula is S sub n equals n over 2 times a1 plus a sub n. So what you do is you take your number of terms. Remember, n is number of terms, so in this case, n equals 10. You take your first term, a sub 1 in this case is 1. You take your last term, a sub 10 is 19. And then all you have to do is plug into the formula. So S sub n is going to be 10 over 2 times 1 plus 19. So S sub n is going to be 5 times 20 or 100. I'm going to show you another example that makes it really clear why you don't want to just add all these numbers up yourself. Take a look at this one. We want the 150th partial sum. So if you were to add all of these up by yourself, you would have to complete the sequence. You would have to put in, we've got 1, 2, 3, 4, we have 5 terms. You would need to figure out 145 more terms on your own. And then you would have to sit there and add all 150 terms by hand in your calculator. No, we don't want to do that. So use the formula. And our formula is S sub n equals n over 2 times a1 plus a sub n. So let's see what I have. I have n, 150th partial sum means I want to have 150, those first 150 terms of the sequence. So n here is going to be 150. A sub 1, that's right here, so a sub 1 equals 5. A sub n, that we don't have. But lucky duckies, we have another formula to get a sub n, and that's the one we just did a few moments ago. So a sub n is going to equal a sub 1 plus n minus 1 times your common difference. My common difference, 5 to 16, add 11. 16 to 27, add 11. 27 to 38, add 11. 38 to 49, add 11. That says D equals 11. So I'm just going to plug in. A sub n is going to equal a sub 1, which is 5, plus n minus 1, so 150 minus 1, times my common difference, which is 11. So put all that in your calculator. You get 5 plus 149 times 11, or 1,644. Okay, that is now ready to plug in to our sum. n is 150. We're going to divide by 2. A sub 1 is 5. A sub 150 is 1,644. So S sub 150 is going to be 75 times 1,649. And I get 123,675. And that's our answer. All right, here's our last example. This one's the real world problem. This one comes from the business industry. We have a small business and they sell $20,000 worth of sports memorabilia during the first year. So this is things like hats, t-shirts, maybe posters, maybe jerseys. The owner of the business has set a goal of increasing annual sales by $15,000 each year for 19 years. Assuming his goal is met, find the total sales during the first 20 years this business is in operation. So my advice to you, remember, is to read this 3 times. Your first read is for the story. Your second read is, what do they want to know? Usually you find that at the end. And the third read is for the information. These ones, they can be challenging for students. And the reason is you don't even know what they want you to do until you get to the end of the problem. And by the time you've got to the end, you've forgotten the information. So that's why you're going to read it 3 times. What they want to know is total sales during the first 20 years this business is in operation. So what they want is S sub 20. That's what they're looking for. The information they give us: sells $20,000 worth of sports memorabilia during the first year. So $20,000 first year. That says that A sub 1 equals 20,000. Goal of increasing annual sales by $15,000 each year. That says the common difference is 15,000. So D equals 15,000. So we have everything we need to solve this problem. We know our common difference. We know A sub 1. So the first thing we're going to do is figure out A sub n. And remember, A sub n is going to be A sub 1 plus n minus 1 times d. And what's n? Well, n's 20 years. So n equals 20. So now I just plug in. A sub 20 is going to be 20,000 plus 20 minus 1, which is 19, times the common difference, which is 15,000. So A sub 20 is going to equal, and this is 20,000, so 20,000 plus 19 times 15,000, and I get 305,000. So if they meet their goal, the 20th year of operation, they should make $305,000. All right. Now what we need to do is the summation. So S sub 20 is going to be, let's see, it's n over 2. So 20 over 2 times A sub 1, which is 20,000, plus 305,000. So this is going to be 10 times 305,000 plus our 20,000. So 10 times 325,000, which gives us 3,250,000. So that is our final answer. All right, thank you for watching and have a great day.